Okay, so we're about to start a new video. I think this is video 20, Math 108. We need to talk about measures of variance, something called the variance and the standard deviation. So let me put up a little bit of a title here. Actually, let me move the paper as I sometimes do. Want to get it down a little bit. If I can, yeah, get it down. There, that's good. Okay, so what I want to do is talk about variance. This is in your book. You can find it at, they call it Measures of Variation. It's 11.3, I'm sorry, 11.4 in your book. 11.4 in your book. All right, fine. But this is variance, and that leads, and right after that comes standard deviation. You'll see that they're very, very closely related, pretty easy to get from one to the next. Standard deviation. Okay, so now, let me give you two sets of data. What I need to do is give you two sets of data. Set A, which I'm going to ask you to do yourselves at home eventually, after I show you what to do, obviously, is got the data's got 7 data items in it. 71, 70, these are temperatures. 72, 72, 70. Situation B, which I'm going to be concentrating on more and showing you a formula hopefully soon, is got 84 in it, 84, temperature of 84, 59, 60, 64, 71, 77. Okay, so let's just say, let's go find the average here. Let's go find the average of both of these sets, right? So average, we have this symbol that they like in our book here, which is this, so we'll take it. You add up 71 plus 70 plus 72 plus 72 plus 70 and divide by the amount of data items, which is 5, and that's going to turn into a total of what is it, 350, 355. It's going to be equal to 355 divided by 5, which is going to be equal to 71. There's your average. Okay, let's take the other side, B. 84 plus 59 plus 64 plus 71, I don't need that, plus 71 plus 77 divided by the amount of data items, which is 5. Add those up, and you'll also see that there are 355. But we divide by 5 equals 71. But they're very different sets of data. These temperatures are very close to being close to each other. They're clustering very near. They're all clustering near the 71. And they're very close to their average, but these fluctuate. 71 is good, but 84 is way away from the average. So is 59 away from the average. And even 64 and 77 are not that close. So they're very different data. So just because you get an average, the average, it really doesn't tell you. It tells you does a good job for case A, but it does not do a good job for case B. So they came up with something called the variance and the standard deviation to help us figure out if the average is good, is a good barometer of what's going on, or not so good. All right, so here comes the formula. There's no argument in the various books about the symbol here. This one everybody admits, and the way you have it in your book is with an S. I guess they just figured forget about the Greek. They don't need to use the Greek, and they just call it S. So S squared is going to be the variance. S itself, so the variance is going to be S squared, and the variance is going to be a square root away from that. It's going to have the symbol S, standard deviation. Okay, so S squared is equal to, here's the formula. Here's how you do the formula. What you need is, in order to use the formula, what you need is you have to have the average, which we already did. So it's the average minus the first data item squared plus the average minus the second data item squared, etc., 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 until you finish with the data item. So if there's 5, when you get through 5, you're done. And what do you divide by? You divide by n minus 1, which is the total amount of data items. Let me put that over here. Some information right over here. N is equal to the number of data items. So obviously, n minus 1 is 1 less than that. So in our case, where there's 5 data items, so let me call this scrap paper, and I'm also giving you some information with that scrap paper. There are 5 data items, so n minus 1 is equal to 5 minus 1 equals 4. That's what we're going to be dividing by eventually. Okay, so watch this formula in action. Case B, right? I've cordoned off A. I want you to do A yourselves. Try that when we're finished yourselves, but I want to do case B. All right, so what's the average? We figured it out already. It's 71. Minus what? The first data item is 84. Okay, fine. Minus 84, and then square it. Plus 71 minus the second data item, which is 59, and then square it. Right? Do I have it squared here? I don't know if I have it squared here, but I need one. Squared, it's always squared. Apologize. Then we go to the third item, 71, the average, right? Minus 64 squared. Then 71 minus 71 squared is going to be 0, but that's okay. And then finally, 71 minus 77 squared. And we've run out of data items. We've done all 5. 1, 2, 3, 4, 5. Divided by what? This is s squared. I've got my equals. I'm getting small things here, but they're important. So this is variance. The variance is equal to all of this, following the formula, exactly the formula. And then n minus 1 is the total of 5 of them. There's 5 of them. 1, 2, 3, 4, 5. There's 5 of them. Minus 1 is equal to 4, so you divide by 4. Okay. Let's continue. 71 minus 84 is minus 13 squared. It's going to turn positive pretty soon, but it starts off as a minus 13. Okay. Then, after that, when we're finished with that, we've got 71 minus 59, which is going to be positive 12 squared. So you can put it in parentheses or you don't have to. It's up to you. 71 minus 59 is 12 squared. It's not a negative number, so I don't need it in parentheses, but if you want, you can put it in. It doesn't hurt. The next one, 71 minus 64, also it's positive. That's going to be a 7 squared, so I don't need the parentheses. It's optional. 71 minus 71, let's record that it's here. It's going to turn into nothing, but let's record that it's here for clarity's sake. And 71 minus 77 is going to be minus 6. So that I need a parentheses for, squared, and all of that divided by 4. Okay, now I might have some room over here. Minus 13 squared is 169. 12 squared is 144. 7 squared is 49. And 0 squared is nothing, and negative 6 squared is 36. Divided by what? Divided by 4. Add those 4 numbers together on top in the numerator, and you get 398. 398 divided by 4. And when you do 398 divided by 4, you get 99.5. So finally, if you're asked for the variance, which symbol is s squared, you say, here's your answer, 99.5. Problem over. Now, I need some more room. I think I've got it. Let's push this paper up. I've got a pretty good room. Now, let me go off on a tangent. I go off on a tangent. You've seen that during the semester. Going off on a tangent. I'm winning a little box over here with a tangent. Now, if you were told x squared is equal to 16, and they asked you to get x, what would you do? Take the square root of the left, take the square root of the right, and you get x is equal to 4. Now, it's really 4 and negative 4, but we're only interested in the positive thing here for when we're dealing with variance. So if we want to go from s squared to s, remember, the s squared is variance, and we set up there, but I don't want to lift the paper, we set up there that s is equal to standard deviation. So what if they ask you for the standard deviation? What do? Well, if s squared is equal to 99.5, then take the square root of the left and you'll get s. That's the standard deviation. If you take the square root of the left, you got to take the square root of the right. So the s is equal to, I don't have the calculator on me right at hand. You take out your calculators, go check out what this number is, take the square root of 99.5, and whatever that number is the answer for standard deviation. So what are you asked? Are you asked for both? If you're asked for variance, this is your answer. Here's the answer. If you're asked for standard deviation, then whatever the square root of 99.5 is, there's your answer. So if you're asked for both, you got to give both these answers. That is how to deal with a variance problem or a standard deviation. It's all in the formula. Let me show you the formula right over here. It's still up there. The formula for variance is you take the average minus data item number 1, then data item number 2, square it, data item number 2, data 3, until you run out of data items, and then you take all the data items, count them up, and do -1, put that on the bottom, and then you have to just tediously go through all the numbers, and then you get to the variance. When you get to the variance, you're one step away from the standard deviation to take the square root of the variance, and you've got the standard deviation, and you're done. Now, what you need to try right after this video is the case A. You need to try case A, which is up there, right? Which was, I'll show it to you again. This way you don't even have to lift the paper. It had 71 in it, 70, followed by 72, 72, and 70. Go find, you need to try, find the variance and the standard deviation. And here's what you're going to find. This is a big number. Let's go with the variance. This is a big number, this number, 99.5. Our variance is 99.5. I have it in 2 places right here. The variance is very big. You'll see the reason why it's so big is because these numbers, 84 and 59, these temperatures were way far away from the mean. But when they're really close, all the numbers are close to the mean, all the data items are close to the mean, you're going to have a very small number for your variance and your standard deviation. Here you have big numbers because the variance is telling you that the data items are straying far away from the mean. In this case, when you try A, you'll see it's a small number because the data items are not straying far from the mean. That's how variance, that's what the role that variance plays. Okay, this video is done.